Hello, so my name is Govind Girish. I am one of the team members and I'm also the team captain for the Westwood Robo Warriors, Team 2583. And I'm making this video mainly for my team. Just a couple disclaimers beforehand. So I'm using some really sketchy software and it is a trial version. To record my screen and record my audio, so I can only do this in 10-minute intervals. So if I cut off halfway, just go to the next video. I plan to put this on YouTube. I say that now, but who knows where it's gonna go. Anyway, you can see me moving my mouse right there, and I'm drawing a square on my screen. So I was going through the interwebs trying to find a good tutorial for my kids to learn SolidWorks, and it really got to me that there was good resources for SolidWorks in general, but there was nothing for SolidWorks and designing something as basic as a chassis. So in an effort to finish that, I have made this chassis. Now it is basic, and when I mean basic, I mean like, here, let's view this a little bit better. Shaded with edges. I mean like Toyota Camry basic. That's how basic this chassis that I'm recording here is. And you know, that's okay, because it does teach a lot of good techniques. So yeah, so we're gonna start off, and I'm gonna build this with y'all. So we're gonna start off real simple. So if I look at the top view here, I just click this little top view button. It's an H, kind of. It's I don't know what to call it. It's like two bars with two middle bars. I'm, again, not a pro at this, but pro enough to teach my team. It's a chassis, and it's a working, good, basic chassis, and I'm talking so basic, like, I drive a Honda Accord basic. So let's get started. So I'm gonna build this thing first, and I'm building this and that. Those two are the exact same thing. They're identical. And so this is an assembly, and within that you've got different things in that assembly. Some of it is inside, which is why I'm clicking. Yeah, see the wheels. You can see like the stuff that I'm clicking here, the 16th inch things, they're on the inside. There is a lot of stuff going on. You see that blue part? That is it. So without further ado, let's build our new chassis. So I'm going to click new. I'm going to click new part, and I'm going to make a 2x2 aluminum tube. Now it has come to my attention because I'm a senior and I've been in here for 3 years. I've been on the team for 3 years. This is going to be my 4th year. It has come to my attention how useful aluminum tubing is, and all the teams are using it these days. So useful, so simple. Simple is the biggest thing. So I've basically just made this rectangle with a 2x2 dimension, and now I'm going to offset it. I click that. You can see the yellow line all around it. First off, I'm going to reverse the dimension, so it's offsetting inside. Then I'm going to make it 1/16, just to make my math a little bit easier. Delete that, and I'm feeling a little bit bold, and I'm going to make this longer than my original chassis. I made my original chassis tube 24 inches long. I'm gonna make this 30 because I'm a rebel. Okay, so there you have it. Now I'm going to save everything into a folder I have a robotics folder, and I'm gonna make a new folder called Practice Drivetrain 2. And I'm gonna make this side aluminum tube 2x2. Okay, so my name is saved up there. I've got my part right here. And so now it's time for me to really go into one of the hardest parts about building a chassis. And to me, that is, where do I start? Well, a chassis, and I think the better term for it in FRC is drivetrain, because a chassis in the real world is just a frame. Whereas in the robotics world, it's a drivetrain, because your chassis and your wheels and your motors are all connected in the same thing. So, I'm going to go over here. You can see that I was trying to download some video screen recording stuff. I'm going to then go to one of my favorite websites in the whole world, vexrobotics.com. Now, Vex Robotics is unique and beautiful because it has so many different parts. And, they did release new parts for 2016. I wonder if we'll ever be looking at that. I'm going to hit View All Parts. I scroll down. And actually, let me scroll back up and go here. Vex has one of the best selections of gearboxes I have ever seen. And I'm not going to lie, and please don't laugh, I spent hours here trying to figure out how all of this stuff fits together. Like, this, it looks easy. Like, when I first looked at it in the summer, I was like, wow, we should really make something out of that. But then when you actually get to it, it's a little bit harder, but it is still relatively so easy. And the best part about it is that it is simple. Easy and simple are not the same. Easy is, I guess, easy to understand. Simple is it works simply. So we're going to use this. It has 2 sims. We're not going to use the 3 sim version. So this is the 3 sim version. We're not using that, okay? We're using the 2 sim version. And furthermore, I'm going to go scroll down all the way to the bottom right now. We're using, not all the way to the bottom. So I went to CAD models. We're using, so it says DS. I don't know what that stands for. WCP, West Coast Products, Dual Speed Base Kit. Now these top 2 only take 2 sims, and on top of that we're only using the base kit. So I'm gonna click that, and oh look, something downloaded. That is my motor. Alright, go in here, I just extract all. Okay, so there it is. I'm gonna just copy that. I hit Control C just now in case you didn't know. And I'm gonna open a file. There we go. I'm gonna open this step file, and so my 10 minutes are almost up for my first video. But basically I'm going to, when it gets to it, save everything and move on with my life. So it's processing 71 trimmed surfaces. I don't know why it has to tell me that. I guess it's showing off. But what I'm basically going to do, because my time for the first 10 minutes is almost up, is just going to hit this button right there. Just hit save and save it as standard gearbox. So save it as a assembly. Right. Hold on. I'm going to highlight everything, right click and say fix, so that way when I drag apart it doesn't move off. Then I'm going to save it as an assembly, and I'm going to save it as alright, let me pause right here just so And I'm back. So my 10 minutes cut off, but I'm back now. So we just left off when I highlighted everything and I hit right click and I said fix. Now it says float because I've already fixed it. Just to let you know what happens. This is how it was before. I can just, do that. It's not something that I want to do. So I have highlighted everything. I right click here and I hit fix, and all of a sudden everything's grounded. So I'm gonna save this. I'm going to go back to my robotics folder and I'm gonna say gearbox. Now that's a really bad naming convention and I don't encourage you to use it, but because of your sake and because of time's sake, I'm going to just name it gearbox. And it's saying, oh look, it's an assembly, I gotta save everything under the assembly. Okay, fine, be that way. No, I'm just kidding. That it has to do that, so go ahead and let that happen. Okay, so couple things. We are going to make this dynamic as possible, so it is going to be a long set of videos, but especially for my kids, I do think it's worth going through. So I'm hitting Control Tab, just cycling through things. I can do that using Control Tab. Side aluminum tubing. Okay. So, actually, let's go back to the gearbox just real quick. The gearbox, and it took me so long to figure this out, fits on anything. And let me get a side view here. Like so. You see that gap right there? This gap. Your metal actually goes in there and this screws in through the metal, through this piece, through that, through this nut, and it ends right there. So that is that entire screw. So yeah. Control Tab, go back here. I'm going to sketch on here. And notice how it didn't rotate to where I wanted it to. All I got to do is press this little button here, and that makes me normal to, and yes, I said that correctly, normal to the sketch plane that I want to work with. What normal means is that I'm facing it directly. How you can get this little bar right there is you right click, standard views. Right click, standard views. It's back right there. Okay, so I want my gearbox to be in the middle of this aluminum tubing. So what I'm going to do now is, well, a couple things. I guess what I could do is, you see how that midpoint popped up? Make a line right there, hit escape, one more line. Where's the midpoint? Midpoint to midpoint, escape, and there's my center right there. So I'm going to draw a circle, just a random circle. You see how those two intersect right there. Doesn't matter what size circle it is, it's a circle. And so I've now exited out of everything. I've exited out of everything. Wow, my English is bad there. And I hit exit sketch. So there is my circle. Now, what I want to do is not just have a circle, but what I want to do is have a bearing. And bearings are cool for a couple of reasons. Bearings are cool because they allow you to have really smooth surfaces that axles can rotate on. So this is a hex axle, and you'll notice it's called a hex axle because it's got 6 sides. Oh, that was a circle. Okay, just trust me, it has 6 sides. And this is a bearing, and what that does is it allows it to rotate really smoothly within a circle. Now you've got a bearing on your gearbox, you really also need a bearing inside your aluminum tubing. So first things first, I'm going to see what type of hex this is. I'm going to hit evaluate, measure from this side all the way to this side, and it turns out to be 0.5. So this is a 0.5 hex shaft. Why is this important? Well, it turns out when you go to the Vex Robotics website, the Vex Pro website, I'm going to hit View All Products. Go down, go down, go down. Bearings. Ooh, bearings. Okay, so now if this is a flanged bearing, this is a radial bearing. Flanged, radial. Flanged, radial. We're using flanged ones. The flange allows us to put it inside a sheet metal hole and like not slip out. The flange prevents it from slipping out. So, which one do we want? Well, we want a 1/2 inch hex, right? Where are we gonna find that? Flanged bearing, 1/2 inch hex. Yep, this looks like it is it. So I download it, show in folder. I have to go through this lengthy process again. Sure, why not? I'm gonna hit that Control C, go back to SolidWorks. Get out of there. Control O, so I open something. Control V, and I'm opening this. Yes, I want to import diagnostics, whatever that means. I really don't know what that means, but it has never hurt me since, so I just click yes. Practice drivetrain, and now I'm going to save it as standard hex bearing. Bearings. Okay, so that bearing is supposed to fit in here. And if I look on the actual practice chassis that I made earlier, there's actually a bearing. That's a bearing right there. You can see it too. This is that bearing. And it's blue. You can see it in blue right now. So it's there. It helps a lot. It's necessary. There's also a similar bearing on the other side that I just clicked, and now it's blue. You can even see it's blue on the inside. Okay, so I need to fit that bearing right through the middle. And so what I'm going to do is Control Tab, go to the standard bearing, and I'm going to measure this hole. Evaluate, measure, right there. The diameter is 1.124. No, it's not 1.125. It's 1.124. And actually, every time I CAD, I have a notebook beside me, and I have a notebook right now beside me, and I'm going to write that measurement down. Alright, exit out of there, exit, escape, escape, Control Tab, side aluminum. So what I'm going to do is so I made this sketch, right? I made this sketch. I'm going to right click that sketch and hit edit sketch, and now I'm going to dimension it 1.124. Sweet. I'm also going to get rid of that line and that line, and all I did was hit the line and hit delete. Exit the dimension stuff, exit the sketch. Now I'm going to click the sketch so it's highlighted and hit extrude cut up to surface, and what that means is it's asking me to click a surface to extrude to. I'm going to click that surface, and watch what happens when I hit check. There. Nice, huh? So that is the hole in which my bearing needs to go into. Alright, good deal. So my second 10-minute session is almost up, so I'm going to hit escape on my audio and video right now. Okay, so third 10-minute session. I've just made this hole. I haven't even moved my computer screen. Don't worry about it. So I'm gonna save it, and I'm gonna open, I'm just gonna hit New Assembly. So I'm gonna drag in this tube. So what I'm gonna do, actually, let me just show you. So on this drivetrain that I made, I'm going to make that 1/2 right there. So that's important. Why is it important? Well, that is 1/2 of our drivetrain, and we can replicate that and make a full drivetrain out of the 2 halves. So I'm going to now, I've inserted this tubing into this assembly, and I'm going to insert one more component, the gearbox. Ooh, gearbox. So I'm also going to insert a standard hex bearing. So what I'm going to do is hit mate. And again, one other disclaimer. There are plenty of ways to do the same thing in SolidWorks, okay? For my students who have been through the SolidWorks tutorial program, just get the basic idea down. I don't care how you made it and what surfaces you do. If you don't know, first off, you really should. Secondly, just know that I'm mating these surfaces, but there are many different ways to do it. So I'm clicking that. Wow, that was really choppy sentence I just did there. Concentric. So now those 2 circles are concentric. Check. And I'm gonna make that surface and this surface coincident. And wow, what do you know? It spins. So that's good. And I'm gonna do the same thing on this side. I'm gonna make this and that concentric. And I'm gonna drag it out just a little bit. I'm gonna make this and that coincide. Now notice how it's flipped. All I gotta do to flip it back is hit this button. And there we are. Okay. So I have made a side tube with bearings, and there's this gearbox on the side. So what I want to do now is hit this gearbox, not hit this gearbox, place this gearbox over there. How do I do that? Let's see if I can remember it correctly. Please bear with me. I'm going to mate this side with that side. So now they're on the same plane. They share the same plane. As you can see, I tried to make it a little bit better. But I also want them, concentric, right? So I'm going to hit that circle and hit this circle. And now they're concentric, which is good. However, it can move around like that. So what I'm going to do, the last thing I'm going to do is hit this flat surface, and now they're parallel. Those planes will always be parallel. Hopefully that's a better view. Hit check. Is it going anywhere? No. You can see that the screw hits out just a little bit there. What I'm going to do now is make an adjustment to this part while it's in an assembly. And I don't know whether they teach you this in SolidWise. I think it's the single most useful thing you will do in SolidWorks. So what I'm going to do is I'm going to right click the part, and I'm going to hit edit part. Yeah. So first I got to save the assembly. I'll just say drive train half. Save all. Yeah. Long story short, I have successfully made it so this part can be edited. Now, there are a lot of settings to play around with. And I'm not going to get into it, but basically, sketch, hit that. Okay, so basically, I want that circle. So the center, the center of that circle is right there. Okay. I don't know how big to make that circle, so what I'm going to do is I'm going to hit, we'll get out of there, evaluate, measure. Yep. I think I might have to exit the component, so what I'm going to do is evaluate, measure, and what do you know, it's 0.19. Okay, so I got my notebook right next to me, 0.19 underline. So yes, I'm going to keep track of that measurement, because now when I go back, I'm going to go back to the side aluminum part, hit edit part. I'm going to open it up actually, and I see my sketch is still there. I'm going to right click that and edit sketch. So right now I'm editing a sketch inside of a part, which is inside of an assembly. Lots of steps, but you can do it. I believe in you. So what was that measurement? I don't remember, but it's a good thing I wrote it down on my notebook, which is right next to my computer, 0.19. And look, it fits perfectly. I'm going to hit out of the dimension, hit out of this, hit exit sketch, and then I'm going to go to the features tab. Now notice how this edit component thing is still highlighted. Extruded cut. Sorry. Let me select the sketch. Extruded cut. It's asking me how far do I want to extrude it to. Well, I really don't want to specify an actual measurement. I want to go to a surface. I'm going to go to that surface. Sweet. And done. So I'm going to hit save, save all. Okay. Well, I want that same hole on the other side, so what I can do is all of those changes actually resulted right there in the actual part itself. And all I did was I control-tabbed over to that part. What I'm going to do now is I'm going to make, well, so I'm trying to, okay, first off, I'm trying to get this hole on that side. I'm going to make a plane. What happened? Oh, it's loading. Okay, so my first reference is going to be this surface. My second reference is going to be I made this 30 inches, right? So I'm going to make it 15. Flip the offset, and there is my plane. Okay, so now what I'm going to do is this, I'm going to mirror it. So features to mirror that extruded cut, but the mirror face, the mirror plane is right there. Hit check, hit save, control tab, and there we go. Now, one of the things that I think some SolidWorks tutorials don't really cover is practicality. How am I supposed to fit this screw inside this tube? Well, the only way to do that is to have this hole bigger than, well, than that hole. And what I mean by that is, keep moving around. Just bear with me. The hole on this side is going to be bigger than the hole on that side, so this head of the screw can fit through. And if you, okay, at least for my robotics kids, if you have any questions, I can easily explain that to you face on face, but I have ran out of my third 10-minute session. Wow, this took a lot longer than I thought it would. So I'm just going to hit cancel and resume on my So I'm back for my fourth 10-minute session. So yeah, so where we left off, basically we have a hole for this screw, but you know, we want it to be accessible so we can actually put the screw in. So this hole is going to have to be made bigger, and it's that hole that I just highlighted right there. So what I'm going to do is I'm going to hit or right click the part, hit edit part, sketch, right there, and I'm gonna make this, let's say, what should I make it? Smart dimension, let's just make it 0.5. Okay, nice easy number to remember. Right, exit sketch. So now that I have this, the actual, sketch, I can hit edit or exit editing the component. My English is really bad today. So now I'm no longer editing the component, and I'm going to switch over to the actual part instead of editing it in the assembly, just because it's a lot easier to visualize it without all the other crap in the way. And you can see that the sketch is there that I just made. Nothing's happened to the sketch, but what I'm going to do is I'm going to hit that sketch, go to features, and then extruded cut. And it's asking me up to the next surface. Well, I'm going to click that surface. And you can see it's only going to extrude that much. Now, I think it's a little easier to see what I was talking about now. You see how the hole on this side is bigger than the hole on that side. Now, I want to make that same hole on the other side. I'm going to hit that last cut extrude hole, mirror it across this plane, check, and there we go. Save everything, Control Tab, go back. There we go. Now we have these accessible holes where we can put the screw through. Now, isn't that cool? So, a couple things there. It's good to have bearings. It's good to have access holes for your screws. And so now we've secured our gearbox onto the tube. Now let's see what's the next step. Control Tab. Well, the next step really, okay, well, you see all of this stuff like the sprocket and that spacer and the bearing. Well, all of that is just like, all of what's underneath here is also underneath there. And so how this works is this gearbox will turn this shaft, and this shaft is directly driving this wheel. But also, it's driving a sprocket. You can see that sprocket right there. And that sprocket has chain, which is driving this sprocket. And that sprocket is driving this shaft. And that shaft is driving this wheel. So basically, in short, this motor, or this gearbox, is powering this wheel and those two wheels. So it's powering all three wheels, basically. Well, that took a long time to say. Basically, these two motors powering this gearbox is powering this wheel, and that wheel. So, part of this, I've done the hard part for you, measuring everything out. But what I'm going to do is introduce you to the wonderful world of sprockets and spacers. Now, what is a sprocket? Well, a sprocket, here, let me just show you. Let me just Google it, actually. Sprocket. Okay. So, this is a sprocket. That is also a sprocket. This is the chain going around the sprocket, and basically a sprocket has a pitch. We're using number 35 pitch sprockets. So yeah, basically the number 35 is just the chain type. And they connect chain together. Now, chain is really strong. A lot of teams are shifting from belts in their drivetrains to chains just because it can take more wear and tear. And it's just easier to work with in the long run. Chain is a pain to work with in the short run, but it saves you a lot of time in the long run. So on the Vex Pro website, I'm going to go back to the Vex Pro website. I love this website. It's got everything I need. Well, not everything, but you know. Scroll down. Where is sprockets? Sprockets. Here we go. Number 35, chain sprockets. There it is. There's a sprocket. There are different types of sprockets. That's a single sprocket. That's a double sprocket. That's a huge sprocket. What we're going to be doing, just to make our lives easier, and this is honestly just kind of me being lazy, but the way I see it, why bother finding the right, like, you don't need to use this sprocket. It's just going to make your life harder. Just use that and you've got a whole new tolerance to work within, and it's easier. So that particular sprocket is, first off, we want a hex sprocket. So there are some sprockets with hex holes, there are some sprockets with round holes, which that's a round hole. We're using the sprocket with hex holes, and we're also using the double sprocket. And that double sprocket is this one. This is a single sprocket, that's a double sprocket. Double sprocket with the hex ID, we'll just use the 12-tooth one. Click it, it downloads another lengthy file. Extract all. Yep, sure, why not? Control C. I'm going to go back to SolidWorks and open up that part. Control V. There it is. Okay. Yes. Save. I'm going to go back to my robotics folder, drivetrain 2, and save it as 35 double sprocket, and I forgot how many teeth this was. 12 teeth. Yep, 12 teeth. Sweet. Okay, so Control Tab, go back to my assembly, and I'm going to insert this a sprocket. Where'd it go? There it is. Okay, not exactly where I want it. In fact, it's really far away from where I want it. Where'd it go, actually? Okay, Control Z. I'm going to insert it. Insert the component, number 35 sprocket. There it is, right where I want it. Kind of, not really. Yeah. So that sprocket needs to go in the middle there, but it's not in the middle. And the reason it's not in the middle is because there's a lot of space in between this edge and that edge. So I need spacers, and spacers you can find on the Vex Pro website. Let me just hit the back button instead. On the Vex Pro website, where is it at? Spacers, acetal spacers, axial spacers? I don't know what they are, but they're cool. And just so I can cheat a little bit, let me see which spacers I actually used. Whoa, that's a lot of things. Okay, so let's see. I used a 1/4 inch and a 1/16 inch spacer. Okay, so I'm going to download. So first off, I want the 1/2 inch hex. I want the 1/4 inch 1/2 inch hex acetal spacer and the 1/16 inch acetal hex spacer. I'm going to download both of those on my 10 minutes. Okay, so where did we leave off? So we've got our half drivetrain here. Oh, and we were putting in some spacers. So let's see if I have my spacers. I think I downloaded them actually. And yes, I did. So extract all. Alright. Control C, go back to SolidWorks, and let's make that an actual part that we can use. So a lot of y'all might be asking, why are you opening the part and resaving it? Well, as you can see here, it's saved as a step file, and step files are not easy to work with in SolidWorks. So what we do is we import diagnostics. The computer will figure out what it's supposed to look like, how it's supposed to behave, and sorry, I lost my train of thought for a second. How it's supposed to behave, and then we can save it as a part, like a solid part, SLDPRT. And I'm gonna save this as a 16th spacer. However, we also downloaded another one. Let's extract that. See, notice how it's a .step file. What we're going to do is open it in SolidWorks. Open. Open that. Sure, why not? And save it. And I forgot to save. Okay. A quarter spacer. Didn't spell that one right. So I just noticed that I forgot to save this in the right place. So I'm gonna click Save As, Documents, Robotics, Practice Drivetrain 2. There. Okay, so now I'm ready to add this to my assembly. So these spacers go right on top of those bearings. So what we're gonna do is open the quarter spacer. Wow, I spelled that wrong. We're gonna open that, hit mate, and first I'm going to make this. Well, let's try something else. I was gonna make those two sides even, but I think I'm gonna make them concentric first. Yep. So now they're concentric. Let me hide this sprocket just so we know what we're looking at. I'm gonna mate. It's hard to see in here. I'm gonna mate this face with that face. All right. And now if you wanted to get super technical, you could mate this side with that side. I mean, just to make it more cohesive and make it look like it's actually supposed to be there. I don't care. This is all for concept. I'm gonna add a 16th inch spacer as well. Now, this is a quarter inch spacer. This is a 16th inch spacer. So basically, together they make a 5/16 inch spacer. Same process. Make this and that. Well, you could make it coincident, concentric. They're the same thing, except coincident makes them touch, which actually isn't too bad of an idea. And then I guess what I could do, where am I? Is well, I'm gonna make that and that parallel. Okay. So now I have that. And I'm going to do the same thing on the other side. This is a little bit tedious. I've always wondered if there's an easier way to do this, and I think there is. I think I did learn it a while ago. But, you know, I am too lazy to figure that out right now. Okay. Now I'm going to make this and that align. Okay, and now I'm gonna add that. Mate this edge with that edge, coincident, and we're gonna mate this surface with that face, that edge with that face. So now we have a solid part, and we have a hole for, or we have a space for where the sprocket should go. So let's see, 35 double sprocket, 12 teeth. So the first thing I'm going to do is I'm going to make sure that this circle, again, everything's on the same circle, so it really doesn't matter, are concentric. So now, no matter where I move it, it is on that circle. But I want it fixed, so what I'm going to do is I'm going to make this side with that side. There we have it. Right? There is a little bit of space there. You can see there's a little bit of space right there. But that's okay. I'm not going to worry about it. It's fine. Okay. So, that's that. Now, the motor, these two motors in this gearbox is driving this sprocket, but it's also driving this shaft, and we can attach a nice omni wheel on that shaft. So what I'm going to do is go to my handy trusty Vex Robotics website, Vex Pro, Motion, Wheels. Alright. And I like Omni wheels, we're gonna go with that. These are different options. We're gonna choose 6-inch wheels. A 6-inch omnidirectional wheel. Okay. Same process, it gives it to us as a step file. We extract it, Control C, and we open it in SolidWorks. Let's first save everything here. Alright, so we open it in SolidWorks. Come on. So Omni wheels are basically wheels on wheels at 90-degree angles, and they allow for really easy maneuverability in turning. I'll explain some of the positions of Omni wheels, which is important. Please don't tune out, if anything, for this bit, because your robot, you'll notice that your robot isn't performing as well if you don't position your Omni wheels correctly. I'm gonna save it. I'm gonna save it in my trusty robotics folder. I'll say 6-inch Omni wheel. Now notice it's an assembly, so we save all the mini components in the assembly. We're not going to bother renaming all the mini components in the assembly, as long as the assembly itself is something, or the name for the assembly itself is something we recognize. Now, let me open the so this is the actual drivetrain that I built. Okay. Okay. So, what happened? So there are two hubs here. Now, if you notice, on the Omni wheel, it's round, but they've got these like clever little patterns here to place hubs on either end, and that's what we're gonna do. So, I'm gonna go back. Gonna click back. All of the hub patterns on Vex are standard, which makes it really easy and nice. Versa hubs. By the way, my 10 minutes is almost up, so I'm gonna hit cancel and just so I don't know what happened to my video. It cut off for a second, but basically all I did was I went to this Versa Hub page on the Vex Robotics website, and I downloaded that first CAD model in the CAD Models tab. So here it is actually, and I'm gonna extract it. And I was talking about I really hate doing this. Oh, looks like I already did it. I hate doing this just because it's a pain. I don't think it's necessary at all. Let's see. There it is. There is the Versa Hub. So the Versa Hub will allow us to transfer the energy in, or the motion from the shaft onto the wheels. Yes. Yes, I will. Okay, so I'm gonna save this as, make sure to save it in the correct place this time. Documents. Versa hub hex. Okay. So what I'm gonna do is actually, before I start, I'm going to first save everything, so I don't lose my progress. Then I'm gonna make a new assembly. And how this assembly is gonna look like is I'm gonna have that Omni wheel, and I'm gonna have that Versa hub. And I'll show you how this works. Basically, I make this and that concentric. I make this and that touch. And now what I'm going to do is I'm going to align some holes. I'm going to make this hole align there. There you go. And I'm just going to do the exact same thing on the other side. Actually, it looks like those two are not, like those two interfere with each other. I'm not sure if you can see that. Let's undo a couple things then. Alright, let's insert the Versa hub. I think I hit Control C too many times. Let's see. I'm gonna go here and then there, so those are concentric. I'm going to make sure that these are concentric. There we go. Concentric. And then I'm going to make these two faces concentric. Alright, sweet. So that's how it's supposed to look. And now what I'm going to do is I'm just going to do the exact same thing on the other side. Insert a Versa hub. Make sure that these two things are concentric. And if you don't know what concentric means by now, just stop what you're doing and look it up. You're not gonna get anywhere unless you know what it means. Well, I mean, okay, fine. You don't have to look it up. What it means is that two circles share the same axis of rotation. Well, I guess that wasn't too hard to understand. So yeah, there is your wheel. So I'm going to save this as Omni Wheel Assembly. Save everything, blah blah blah. And I'm going to go Control Tab into my half drivetrain. I think I'm going to need a spacer. So I'm going to add a spacer there. And it's not that I think we're going to need a spacer. I know we're going to need a spacer because the last time I did this, you needed a little space. There you go. Alright. And just to make things look pretty, I'm going to line up that edge with that face. There you go. Alright, so now I'm going to insert that Omni Wheel Assembly. Okay. So, it doesn't look too great right now, but what we're going to do is we're going to mate this face with that spacer. Okay. We're going to mate this side of that hub on here. And now just pick another side and mate that. There you go. So now it's, perfectly on there. If you look at, so the reason I added the spacer is if you look at it from the top, now you have, a little gap. Without the spacer, this wheel will be touching that surface, and that's just really, really bad. So now what are we gonna do? Well, we need to add 3 other wheels on each, okay, sorry, let me rephrase that. Each side has 3 wheels, right? So you need a wheel here and you need a wheel there. So how are we going to do that? Well, let me go back to the aluminum tube. And just rebuild everything to make sure everything's updated. If I make an Omni wheel hole at the same height as this one, it will drag. So what I'm going to do is, here, let me just show you. I'm going to make a hole. I'm not going to make it 1 inch. Okay, if I made it 1 inch, the height of this wheel would be the same as the height of this wheel. I really don't want that. I want the height of this wheel to be higher, so there's a little bit less drag, but there's still enough motion. So I'm going to make it 0.95. And I have my trusty notebook, and I remember, actually, let me hit edit sketch again. I remember that the dimension of the hole, because we're going to use bearings again, the dimension of that hole is 1.124. Sweet. So, exit sketch, extruded cut. Well, let me highlight the sketch first so it saves me a couple steps. Then I hit extruded cut up to surface, and I'm going to hit that surface, extruded a cut all the way to that surface. But I want one on this side as well. So real easy, all I got to do is highlight the feature, hit the mirror function. The features to mirror already has my cut or my extruded circle thing. Gee, my vocab is off today. And the mirror plane is that. So there I have it. Hit yes. Oh look, what do you know? So I'm going to hit save, rebuild, go back over here, and what do you know? It updated into my assembly. Could I have done this in the assembly itself? Yes. I just think it's a lot easier to see what's going on when you're dealing with one part and one part only. So let's just deal with this side, okay? Same process, like almost the identical process, really. Let's put a standard hex bearing. So I'm going to make this concentric with that. Let me flip that actually. Yeah, that's not what I wanted. So what I'm going to do is go here, delete. It might have worked for you, but I want that concentric, not coincident. Concentric. I'm going to flip it too. And I want this face, and that face even. Exact same thing on the other side. Okay. Same thing, concentric, concentric. I'm going to flip it. And I want this face and that face even. Alright. Okay, so now I gotta add my spacers, but my 10 minutes are almost up, so I'm just gonna do that in the next 10 minutes. Okay, so I'm back. We had just placed these hex bearings right there. Now I need the same spacers, these spacers. So how do we do that? Same process, quarter spacer right there. Let's make this and that concentric. Let's make this and that coincident. And just for kicks, let's make this face and that face parallel. So now what happens if when I rotate this, the other thing rotates as well. Same process. I know it's a little bit tedious, but it is necessary. 16th inch spacer. You can do a coincident. Same thing as concentric, except now the edges are touching. And let's make those two faces parallel. and now again, if I rotate anything, the spacers rotate with it. Insert another 1/4 inch spacer. I'm going to make this face and that face coincident, this and that concentric, and make this face, and we could put any face really. Well, so now they're parallel. If I hit the flip button, oh, see, so now it does satisfy the mate requirement. This face and that face are parallel, but I want them touching, so I'm going to flip it. And now they're touching. Okay, so last thing, well, not the last thing, but the last spacer we're going to ever need. Oops. Insert component, 16th inch spacer. Let's see. What do I want here? I want that edge and that edge coincident, and I want this and that, I guess, touching. Sweet. So, what does this mean? I now have something where if I rotate it, it's going to rotate within the bearing. What I also need now is a sprocket. Let's see where that is. I wonder what I named it. I think I named it 35. Oh, yeah, there we go. Sprocket right there. So, that circle and any circle really on that axis concentric. This face and that face coincident, but they're not aligned. So what I'm going to do is say this face and that face are parallel. But I also want this parallel with that. Sweet. So now here's what happens when I rotate this. Everything rotates. Wow, that's pretty trippy, huh? So that's we're almost done, really, with this half drivetrain. I need a hex shaft going through it because right now nothing's holding it together. Like if I assemble this, it would just fall apart because there's no hex shaft in the middle. So let's see if the Vex website can help us. Hardware. Shaft stock. And it turns out that yes, indeed, it can. So we're going to do a 1/2 inch hex shaft. Stock. I don't know what the stock really means. 18 inches. This is the exact same as that, except this is longer. We're going to modify it anyway, so it doesn't really matter which one you pick. Just pick the 1/2 inch hex stock shaft. Oops. Extract all. Controls, or nope. Control C the place where it's located. Go back to SolidWorks and open up that part by pasting the location there. Oops. Oh crap. What happened? I thought I copied it. There it is. Control C. Control V. There it is. Alright. So here's what I want to do. I really only want, like, let's just make an easy number of 5 inches. Okay? I only want 5 inches. So this is 18 inches. What I'm going to do is just sketch on the top from there all the way to there. I'm going to widen it just a little bit. What am I doing? Things are going haywire. Alright, so let's try this again. Alright, so if I want 5, I'm gonna make this 13. Exit sketch, extrude. I'm gonna extrude everything really. And there. That's my part right there. I'm gonna save this in my robotics folder, and I'm gonna save this as 5-inch hex shaft. Control tab back to the drivetrain. Let's insert that shaft that we just made. Okay. So how we do that is we make this face touch this face, and we make this face, or any other face really, touch that face. So it's rotating. However, it can also pull in and out. That's okay for now. We'll let that go. We're gonna insert that OmniWheel assembly. Oops, we're also going to insert that 16th inch spacer right there. Same process. Man, this is getting tedious. Okay. You know. Okay, I want one of my edges, which why is it not allowing me to get that? This edge with that edge. There we go. So now it rotates with it. And now I'm going to put that OmniWheel assembly that we just inserted on the exact same place. Okay. Alright, sweet. And now it rotates all together. And it's easier to see here. When I pull this down, it's rotating. Okay. However, what happens when the wheel falls off? Like, what if, the wheel might just fall off? So, this is such a bad way of doing it. It's just easy to show you in CAD. Generally, you'd use things like C-clips or E-clips. I'm going to use something called clamping shaft collars, which are these. And you might have seen them before. We're going to use the 1/2-inch hex clamping shaft collar. Click that. Same process. Gonna hit extract all. I'm gonna copy the location of this file into SolidWorks. Open that file. And my 10 minutes is almost up, so let me just stop right now and you can pick back up in the next section of the Sorry, I don't know what happened to my video. It cut off a little bit, but in short, all I did was I saved that part that we just took off the Vex Robotics website. My computer shut down, so I don't really know what happened. But as we did in the last video, we went to the Vex Pro website, hardware, clamping shaft collars, and we downloaded this one. We downloaded that one, and all I did was the same process we've been doing all day. I opened it up, I saved it as a solid part, and saved it with that name. So what am I doing? So back to this. I'm going to insert components, standard hex clamp. This is what it looks like. And basically it just stops things from moving around. It's got this little hole here that you clamp onto it. It's pretty cool. And I'm going to make this, I guess, concentric with that. I don't know where it went, but there it is. Where is it actually? Nope. I don't know where it is. Where'd it go? There it is. Okay. I'm going to first, I guess, make this and that on the same plane. And then I'm going to make it concentric. Okay. And same process that we've been doing all day. This one's a little bit harder to see, but I'm going to make this side and that side parallel. Oh, that didn't work, did it? Okay, let's try that again. Just going to make that side and this side parallel. There we go. So now when I rotate this, everything rotates. Because of that, I'm going to make sure that no tube sticks out, so I'm going to make this and that face align. And look, it looks like we got a little bit that sticks out this side. So what we're going to do is put another clamp on this side. Now you don't need a you do not need a spacer on this side. It's unnecessary because I mean this clamp is not going to hit this tube. So same process, this and that concentric, this and that touch, and this face and that face. I don't know what happened. Let me try that again. Let me try that again. This face and this face. What the heck? Oh, wow, I wasn't even selecting the mate function. So let's try this again. This face and that face are parallel. Sweet. So here's what happens. You know, the gearbox is turning this shaft and this shaft is turning that wheel, but the two sprockets have chains running through them. This is sprocket 1, that's sprocket 2, and it's also turning this wheel. Okay? Now we have to do this entire thing again. Wait. There is an easier way. Because I sure as heck don't want to do that again. And first I'm going to save everything. I'm going to also hit this rebuild button. If you ever have an error, almost all of the time you can solve it by hitting that rebuild button. If you hit this rebuild button and you still have a ton of errors popping up, then you know something seriously is wrong. I'm just going to minimize stuff so I can see it easier. And I'm going to make this entire thing that we just did its own assembly. Let's see. Nope, wrong one. Okay, I click that and I'm holding the control button. That sprocket, 5-inch hex shaft, omni wheel assembly, and that 16th inch spacer, and these standard bearings. Now I clicked everything. I'm gonna right click and say form new subassembly. Alright, sweet. So it renamed it as assembly 1, which I don't like, so I'm gonna say open assembly, and here it is. Here's our assembly. So you saw that just by picking stuff up I can move it. What I'm going to do now is highlight everything I'm going to highlight everything. Oh, come on. Why can't you work with me? Fine. Highlight everything. Right click and say highlight everything, say fix. That should do it, right? Nope. I'm gonna have to play around with this a little bit, but basically I want everything to remain still. And right click and say fix. There we go. There we go. And I'm gonna save as drive wheel assembly. Okay, so now it's resaved, and if you look here, the name changed. So I want to put one on the other side. Super simple now. All I got to do is insert another drive wheel assembly. It works just like anything else now. I'm gonna make this and this coincide, and I'm gonna make that and that. Let's first view this in a different way. Shaded with edges. That really helps. I'm gonna make that. Why is it not working? Oh well. And that coincident. Okay. Yep. So, Control S, rebuild and save. Alright, and there you have it. There is your half drivetrain. Now, the next part is super easy. It's so easy that sometimes I wonder whether I should even go through it, but I will anyway. So, here's what I'm going to do. I'm going to make a new part, and I'm going to make a middle brace. So what I'm going to do is sketch on the right plane, make a rectangle, make it 1, make it 1 by 2. I'm going to offset. I'm going to offset on the inside. I'm going to offset it 1/16, which is the standard size for aluminum tubing. And now with this highlighted, I'll click extrude, and I'm going to extrude it, let's say 2 feet, 24 inches. Sweet. I'm going to save this as middle brace, and now finally I can make my final assembly. I'm going to have a middle brace right there. I'm going to insert a drivetrain half. So what I'm going to do now is I'm going to mate this. I'm going to mate this and that. I'm going to make this surface and that surface. Okay, so we have here the assembly, and so this can this part I've got here. What the heck? What's going on? Let's rebuild this. Let's see if that fixes any of our errors. Okay, so I want to be able to move this back and forth. The assembly, obviously that's not working, so what I'm going to do is open the middle brace part here, mates in the assembly, coincident. Let's delete these two mates, and now it's still not working. Let's rebuild it. It's still not working. Alright, so sorry for wasting your time, but I'm going to delete that part. And I'm just going to add it again. Right there. Okay. Yeah. Just going to mate the two faces one more time. Alright, so now I can move it back and forth. Which is good, because that's what I wanted to do in the first place. So let me first just right click this and fix it, just so this doesn't move, but this can move. And the last thing I'm going to do is I'm going to mate that face that I just clicked and this. So notice what it does. It drags it to the end. Now that's not really what I want. I'm going to use this distance thing, and I'm going to type in 8. Meaning that, yeah, they're coincident, but actually they're 8 inches apart. Watch what happens if I do this. It flips the dimension, but that's just fine. Alright. And I'm going to insert another middle brace right there. Basically the same process. Right there. Right there. Sweet. And so notice how this is also moving up and down, but I can constrain that by mating this face to that face, but distancing them 8 inches. I think I said that correctly. Alright, and we are almost done. Because these because this whole drivetrain half is identical, we can just plop in another one. Make that. Good. Alright. And from here to here, we're going to distance that 8 inches. However, I want to flip the dimension, and we're all set. So, that is our very simple, very basic drivetrain. I hope that taught you a couple things, especially for my kids. I hope it taught you that you can edit parts in an assembly. You don't have to edit parts as a part itself. I hope it taught you how to, some basics of drivetrains. Let me show you something right here. So, I mean, this wheel and this wheel are higher than this wheel, meaning that only two wheels on each side, so 4 wheels in total, only 2 wheels on each side will always be touching the ground completely. And this makes it that much easier to turn, and it's just good practice when driving a chassis to have your outer wheels just a hair higher than that main driven wheel. I also hope it taught you that gearboxes, they don't have to be tricky. Just make sure you read the instructions beforehand. And last but definitely not least, use your resources. Notice how we really didn't make any part here except this tube. Everything we got it from the Vex Pro website. And that just goes to show you there's a lot of good resources out there. Just before I end the video, let me just show you andymark.com. Ooh, they released new products. That's their chassis, and you can see ours looks fairly similar to that, except ours, the wheels don't have an end on them. And what I mean by that is, like, the wheels just stick out the edge, and really that's all you need. You don't need another side right there. Okay, well, I hope this helped you, and go ahead and experiment and stuff. So yeah, thank you, and my name is Gervin Garish. I'm from Team 2583. This is a basic chassis, and